All right, so as we get started, today we're just going to cover a very high-level agenda that will give you some visibility into the connectivity security problem today, what are the common patterns and common challenges that we're seeing in the field, and also Ahmed will provide 5 practical solutions to some of the connectivity issues that you may come across at scale. And finally, we'll just give a high-level overview of some of the market trends and new concepts that are emerging in the field, which we would like you to be aware of. But with that, let's just get it started. So when we take a look at the connectivity security today, and before even we dive into what we observe in the field, Ahmed and I wanted to just provide a short, friendly disclaimer just to make sure that we're all on the same page when it comes to using the word security in a way. And when we say the word security, we are leading with a couple of assumptions. And Ahmed, do you want to share some color on these assumptions for the session?
Yeah, absolutely. I think we're all familiar with challenges that have been issued and people saying, oh, this is secure, you cannot break in. Just to put every one of these, there is no such thing. I remember very well from my college days, a professor says, look, it's all about reducing the risk. And that remains true today in my professional career. The idea is to reduce it to as low of a risk as you can so that you can say, yeah, this is acceptable. You cannot absolutely defend after every possible exploitation out there, unless you have physical security with security guards and weapons and so forth. So not that this is a legal thing and we have lawyers in our family, just Erdem and me want to put everyone at ease to say, look, nothing is ever bulletproof. Use your best judgment and try it as best as possible to defend any threat that you deem appropriate.
Absolutely, and I think it's more about remaining humble and continuing to run through cycles at improving the overall security and reducing risk at a high level. And this reminds me of one of the interesting experiences or observations that we had in the early 2000s. It was one of the global software vendors who claimed that their software was impenetrable, and they almost encouraged wannabe attackers to test their software. And sure enough, in under 24 hours, their software was taken over, and there were interesting cases of breaches to follow that. So again, just another reminder for all of us to make sure that we continue to keep at it, but there's no 100% sure security, or anything can't be breach proof just because we're taking the enough precautions. But now that we've got it out of the way, I'd love to get us started on just highlighting the fact that connectivity today has become the backbone of digital organizations. And when you think about connectivity, it's not only about connecting what's legacy or what's available out there, but it's also about connecting to our customers, to our partners, and also to connecting to new business opportunities. And when we consider connectivity, I think we're all familiar with connecting at the edge, which consists of connecting our internal resources with externally available resources and the external world. But there's more to connectivity than just edge connectivity. Ahmed, do you have any thoughts on this topic?
No, I fully agree with that. We're all familiar with the classic APIs use case where you're doing protections at the perimeter, but increasingly we are now needing to apply security when we have inter and intra application connectivity, which you see represented in this diagram here. And those are topics that are slightly beyond the scope of what we're talking about, but they're nonetheless very important, and we would encourage everyone to investigate them after this session.
Absolutely. And again, when we consider connectivity security, especially at scale, one of the really key problems here is to see what's available out there, what services we have connected, what kind of connectivity types that we're using, and also what kind of vulnerabilities that we may be exposed to. So it's really critical to have that visibility and then taking action toward providing a secure environment. And this is where a high level of security framework comes into play. So security is not just the one single step. It's more about combining people, process, and technology, but it's also about combining multiple disciplinary steps, such as gaining end-to-end visibility, having the ability to encode governance so that whatever we're creating is aligned with the regulations or with the internal standards and best practices that we have in place, in addition to making sure that we can have the same level of control across distributed services, the ability to resolve security and compliance issues faster, and at the next level, having that AI and ML-powered prediction capability so that we can identify problems even before they occur, whether they're security vulnerabilities or service disruptions that may be present in our environments. Ahmed, do you have any Any thoughts or any comments on this overall picture before we dive into the security patterns?
Just to say that it confirms what I've seen. It's never about technology. It's about people, process, and technology. You're never going to have good security if people don't follow the rules and policies that you have. That means good governance, good change management, good compliance enforcement, and so on.
Absolutely. And when we consider security at scale, it's more of a mindset and it's more of a discipline rather than a single feature or a one-term project overall. Mm-hmm. So with that, we would love to share some connectivity security patterns that we have observed in the field and offer some practical solutions to those security issues. So pattern one starts with API gateway, and from a sequence perspective, we are going to follow a very simple deployment, which scales up and which becomes really complex as we go along the way. So please bear with us as we walk you through the different 5 patterns. So for API gateway, Ahmed.
Yeah, thank you, Erdem. As you mentioned, we're going from simple to more complex, and I just want to caveat that these are just 5 patterns. I'm sure there are many more out there, and there has to be many more out there. But for most people familiar with APIs, let's begin with the easy ones so we're all synchronized here. We have a whole bunch of APIs as we do today. Maybe they're secured, maybe they're not. Even if they are secured, they potentially can be secured differently. Well, now all of these APIs can potentially be attack vectors. The classic mitigation to this is to standardize the application of the API policy. Let's take a look at what that looks like, Erdem, in some diagrams. So as you can see here, you have various clients. They could be internal, they could be external. Who knows? We don't really have that visibility that you mentioned, Erdem, which is, traceability, visibility, very important. And you take a look at the APIs, different security applications, and some are not secured at all. This is not what you want. What you want is to go to the next slide, and the next diagram will show you how we have this structured. You deploy a centralized gateway in which all of your API calls are happening, and now everything is secured in the same way and ensure that you have a good single point of enforcement. Very simple. I'm sure everyone can appreciate this. What do you think, Erdem? Should we move on or want to discuss this a little bit more?
Yeah, I mean, just to point out that I think from a security and from an operability perspective, we're probably reducing the number of different components that we have to deal with on a daily basis from thousands, meaning thousands of APIs and connections, to potentially dozens or maybe a handful of different gateways that we are putting to manage this traffic. So I think that's super useful. And can you tell me a little bit about how this relates to identifying whether we're vulnerable for a certain CVE or whether we are able to fix a CVE in a timely manner?
So you still have to manage CVEs. This does not protect you from those. We or ourselves put out CVEs and critical fixes all the time. But now instead of you having to do it where all the APIs used to be, you do it on the instances that you have it running. So you still have to do the work, but now you at least know where it's going to be applied and you have a good level of assurance that you covered all the exposure that you may have.
Yep, I think that's very useful. And one of the key issues that we observe as users on a weekly basis is expired certificates or distrusted certificate authorities. How would this centralized approach help solve those problems?
Yeah, I see this like you go to a browser and your browser warns you, and sometimes your firewall will outright block you. A similar thing, just like you can update your CVEs here if you have certificate authorities that you trust. So in this case, it's not necessarily the users trusting you, but you trusting certificate authorities. This is something that you would, again, centralized, and the gateway can pick this up from your operating system, for example, as another level of automation if you already have that in place.
Yeah. And just as OWASP top 10 web application vulnerabilities are super relevant for web applications, OWASP also has a top 10 API vulnerabilities that are extremely relevant for understanding the risk exposure and the risk levels for APIs. How does this centralized approach help maybe manage those API vulnerabilities in a more effective way?
Now, not everyone is vulnerable to the top 10 vulnerabilities in OWASP. However, you are encouraged to evaluate your API usage, and then you can apply those right there in the gateway. And of course, if you have something like a web application firewall and the like, it's fully compatible. But again, we are back to the points where we're channeling everything to a location where we can apply our controls. So if you take a look at it, Erdem, all 3 of them pretty much have the same theme, which is ensuring you've covered everything that you should cover in a consistent way.
Absolutely. And I think from just playing devil's advocate for a second here, I think centralizing everything and making sure that we run security from a centralized place makes perfect sense in terms of scalability. But looking at it from an attacker's point of view or from a malicious persona's point of view, this also means that there will be a single bottleneck or there will be a single point of failure in the system. How do you address those challenges with an architecture like this?
So you definitely have to put in the necessary controls. Disaster recovery is one approach. If let's say you get a massive DDoS of some type, protections like that are also important. But it's better to know what your exposure is than to not know, I would say. What if you have an API out there which is not completely known, and then your attacker will over time gather all those weak entry points and you don't even know where they came from? So I would rather be in the know and know what my vulnerabilities are than not be in the know. And
Yeah,
then apply
absolutely.
protections whenever you can. Yeah.
Yeah, thank you. So moving on to our second pattern of the day, which is around automation. Ahmed?
Yeah, so now we're really scaling up. Before we collected a few APIs into the gateway, now we have success, and usually success breeds more success. So now more teams are deploying their APIs. And we can funnel this through one team and then make it a bottleneck. But in case it isn't, how do we get to a position where we're sure everyone is doing things in the right way? And this is where APIOps comes in play. We had a wonderful session this morning by our own Melissa Vanderhecht. And if you missed that session, I encourage you all to see it. Here's a practical example of what it looks like. We can look at the diagram, Erdem. Notice we have multiple deployments, different teams, different standards. This is not what you want. Now this is similar to what we've seen earlier, except now it's at a bigger scale because you've centralized things at a gateway. What you would want is what you see in the after diagram, where you have your API ops enforcing the same standards and ensuring the same controls now are applied to the different gateways. Exactly the same as we had before, Erdem, except now we're operating in a much bigger scale and we're ensuring we're not only covering security. As a matter of fact, API Ops will help you with the developer lifecycle, including onboarding, documentation, and quality control.
Yep. So from my understanding, API Ops is very similar to DevOps, more like in the API world and in from a service connectivity lifecycle world. So I think one item that gets me a question here looking at this diagram is how does this relate to the work that developers do on a daily basis? And how does this relate with Git and version control systems?
Right, so the tooling that we have supports all those classic mechanisms that people have. You want to work with flat file or declarative files, YAML files, for example, JSON files, that's supported. CLI tools are there, admin APIs are there. We work very hard to make sure both the deployment and the configuration of all the work or all the computing that you have with us, the connectivity you have with us, is compatible with what you're running on a day-to-day basis.
Yeah, perfect. And one term that you mentioned that really caught my attention there, you mentioned declarative configuration or configuration as code. How does that help developers apply these different methodologies across their development lifecycle? Or what does that mean from a security team's point of view?
Sure. So you never want people to do things manually if you can help it. You want things to be automated as much as possible. And the nice thing is if a developer is working on the workstation, they do their work, they save their work, that then can be replicated with very good accuracy on another workstation or another environment, let's say where you do your testing, your staging, your quality control. So declarative configuration, having that, that blueprint, that version of the truth that is repeatable between one environment and another is really something that you would like to have if you can, instead of doing any manual work whatsoever. You want to avoid that.
Yep. Thank you, Ahmed. And now moving on to pattern number 3 by cranking up the level of complexity and also upping our scale a bit. Defense in depth. Ahmed?
Yeah, here we have an interesting situation. Now, it's not necessarily the volume as much as it is the timeline that we have. Usually when we have a tool, it can be used in ways we did not anticipate. So we have an API, we're using it internally, we secured it and protect it in a way which we are happy with. But as time goes on, teams change, owners change, and now the API is being used and exposed in ways we did not anticipate. So we have insufficient protection. At worst, it's insufficient protection. At best, it's insufficient protection. At worst, we have a deviation where people copy the work that we have and put it completely somewhere else. So the mitigation here is a pattern I've seen some customers use, which is the layering of the APIs and enforcing the right security at each layer. So you get a little bit of efficiency here, and you don't reduce your security or you don't expose yourself. Let me show you what that looks like in a diagram. If you can go to the next slide. So notice here, we don't have only the internal consumers, we have those external consumers represented as the globe. And I specifically put a key in there to say that it's API key, which we are all, know can leak and cause all sorts of headaches for people. And it's usually something you can avoid unless you're sure you have a pretty good network, shall we say, or those keys are rotated or what have you. But you don't want this. You don't want to have your external consumers and internal consumers using the same APIs, the same mechanism. Sure enough, it started with just the internal guys. What you want is what we have in the next diagram, Erdem, if we can go to it. What we've done now is we chained the gateways. So we separated the external consumers from the internal consumers. And yeah, fine, we continue to use API keys, but then that can only be done in combination with MTLS. And I'm doing this just for demonstrating the point that even if you do leak a key, you're still not going to have access to even use the key. Yeah. And those continue on to the gateway that you have before where the APIs are anyway. Meanwhile, your internal consumers continue to work as they did before. So you can see the efficiency here is that we're not duplicating the work. We're not duplicating the maintenance. We're just layering the security.
And I couldn't help but smile when you mentioned with the increasing popularity of a project or of a successful application, it's almost inevitable that that same application will be used for multiple different use cases and will be copied in terms of code base by different teams to use for different purposes. So it's really critical to understand which purpose or which use case that application was designed for, and also take additional precautions whenever we are repurposing projects internally.
Absolutely. That's just good old product management. Mm-hmm.
Yeah, and for this level of, for example, for this added layer of security, there's nothing that's changing for internal users. So they can continue working the way that they were used to working. It's just an additional layer of authentication or level of trust that's added for external users in this case.
Yes, you want minimal disruption. Mm-hmm.
Absolutely. All right, so moving on to threat detection and prevention at scale.
Sure. So now we deployed one gateway, we deployed a second gateway, we deployed a group, we have gateway chaining. Now we have a whole lot of traffic. We are certain that there is someone somewhere scanning us, probing us, looking for things that they can collect over time to use against us. Now we have a huge volume. We are really searching for, a needle in a haystack here. What do we do in order to detect this? And the answer is here, you want really good logging and traceability and constantly try to look for those clues. There are some tooling out there that will help you. It's mostly driven by artificial intelligence, whether it's at the logging or at a web application firewall. So let's take a look at a classic example here. If you have that high of a scale, there are all your external clients. And that looks like you, Erdem, some malicious actor in there, Dr. Erdem Evil.
We have the same perfect haircut, yeah?
I would agree, indeed. So yeah, you're trying to be undetected through all this volume of traffic that's coming through. So how do you defend against that? And this is where we have the next diagram showing that you would use all sorts of logging and metrics. And you can use, of course, the Kong immunity feature with the artificial intelligence to try to detect these anomalies. Maybe it's a different parameter value. Maybe it's a different latency. Maybe it's an unusual response in status codes that identifies to you that you're perhaps being targeted. And this does not actually protect you, just alerts you to that potentially you may be targeted and therefore you should take some action. Mm-hmm.
And just looking at this level, I feel like Kong Vitals does a good job of alerting you about the known knowns, which you can use to identify known problems or known attack patterns overall. Whereas Kong Immunity leverages AI and machine learning to proactively alert you about what may be a problem, right?
That is true. So with Vitals, you probably can have alerting based on metrics that you care about and know are things that are worth taking action on. With Immunity, it's not as 100% sure because it is using artificial intelligence after all, and it's trying not to have alerting fatigue to you. So it's perhaps a low priority in the short term, but it can very well be a high priority in the long term. So you don't want to ignore those for too long.
Yep, that makes sense. And how do these systems interact with existing log management or events management systems, such as Datadog, Splunk, or Sumo Logic?
Yeah, absolutely. You're free to use those tools as well. The gateway will happily forward data to whatever destination of choice that you have, and then you can run your metrics analytics over there. To be honest, we're indifferent about what it is. As long as you do it and protect yourself, we'll be happy.
Yeah. All right. So moving on to our final pattern for today, which is credentials as a service.
Sure. So this is the most complex pattern. I've seen this applied by one of my customers, and I dare say they are really sharp and really strong in their own vertical. I can't mention their name or the vertical for that matter. But the idea is this. If you run an application or run a project and you came upon a mechanism with which you can authenticate and authorize your clients and it's working great. Well, how easy is it to replicate that to potentially other mechanisms out there that may be legacy or maybe new where that standard cannot be supported? Well, if you try to do that, then you can have a whole lot of complexity by introducing potentially proprietary mechanisms for authentication authorization. You don't want that. So as you can see in this diagram, all our consumers are using OpenID Connect. It's a standard, yeah, with all its warts, but it is usable. And then all the APIs at the same time take the authorization information and verify it with OpenID Connect. But that's it. We're only limited to OpenID Connect. What we want is something else. We want to support different authentication mechanisms and separate out altogether the authorization. So how do we do that? And here's what my customers are doing, or this customer has done, is that they will allow you to use all sorts of mechanisms for authentication. And then they will get your authorization information and store it in your session on your behalf, which everyone can support a session over HTTP. And from there, they can use this authorization enforcement over something like Open Policy Agent. So by separating the authentication from the authorization, we expanded the authentication mechanisms we can use. And we separate the authorization. Therefore, it doesn't even have to be enforced necessarily at the gateway. The gateway can pass that knowledge down to these services. And you can see there, Open Policy Agent. That's actually one of the good standards out there that you can use for this purpose.
Perfect. Thank you, Ahmed. And I just wanted to plug in here that Open Policy Agent is supported by our Kong Mesh product today, and it's also supported in beta with our Kong Gateway 2.4, and it will be fully supported very soon. So just two technical ways to incorporate Open Policy Agent and OpenID together in your environments. So moving on to the final section here, which is about discussing two interesting trends that we observe and what they mean for securing connectivity at scale. So cloud-native multi-cloud environments are almost becoming the de facto installations or deployments for most of our customers and most of the large organizations out there. And also zero trust security is gaining a lot of traction in complex environments. Ahmed, can you share your thoughts and opinions on these?
Yeah, sure, Erdem. I'm seeing more and more customers approaching these use cases. So for a lot of the folks out there, you're running in one cloud, or you're running on premise, or you're running on two clouds, but they're separate from one another. Fine, you can standardize. But pretty soon you're going to have those connectivity between different clouds, and you can have applications. Remember when we said inter and intra-application connectivity running across multiple clouds? So that brings a new layer of complexity, and with it, new patterns that you would have to explore. I would encourage everyone to, and actually that works very well with zero trust security, because now we're talking about applications running across clouds that may not trust each other unless they have established that they're worthy of communicating to one another. There's a very good session that our CTO did in achieving zero trust security with Kong Mesh. So I encourage everyone to take a look at that session from a previous event that we've done.
Absolutely. I think that session was at Destination Zero Trust, which was done a month ago. So you can watch those videos on demand. Another exciting session that's coming that will be focused on service mesh and troubleshooting distributed services will be by our very own Cody Diakland presenting this this time next week. So feel free to tune in to the session that's coming around. A more in-depth approach to observability, service mesh, and troubleshooting. So with that, I'd like to thank first Ahmed for a great discussion, and I'd like to thank you all for attending our session. Thank you and have a great day.